Okay, so we're going to now take a look at exercise number 3, and this is the intermediate level questions. Factor to find the zeros of the following quadratics. We have in part A, y equals x to the third minus 81x. So remember when we were factoring in chapter 8, the first thing you always wanted to ask yourself was, is there a, yes, GCF. So is there a GCF here? And your gut instinct might be like, no, because the numbers don't have a GCF, but look a little bit further, look at x's, and they each have at least one x. So it does have a GCF, and they have a GCF of x. So we're going to factor out the GCF of x. So the first thing I'm going to do is I'm going to set this equal to 0 because we are solving this equation for when it equals 0. And we said our GCF is now x. So x times what will give me x to the third? And if you were thinking x times x squared, then you're correct. X times what is going to give me negative 81x? And yes, that's going to be negative 81. And again, I'm going to set that equal to 0. Now, I've got x on the outside. I've got x squared minus 81 on the inside. Now, can I factor x squared minus 81? You should recognize x squared minus 81 as a difference of two squares. So I'm going to go ahead and I'm going to factor that difference of two squares by putting the square root of x squared in the first part of the parentheses, and the square root of 81 is 9, and that's going to go in the end of the parentheses. And I'm going to separate those with a plus and a minus. The rules for factoring a difference of two squares. So now that I have it completely factored, I'm going to do exactly what I did in number 2, and I'm going to set each one equal to 0. This one's going to be simple because x equals 0. There it is. Now I'm going to have x plus 9 equals 0, and x minus 9 equals 0. So over here, I'm going to subtract 9 from both sides. I'm going to get x is equal to negative 9. And over here, I'm going to add 9 to both sides. I'm going to get x is equal to positive 9. So now I can see that this equation is actually a cubic function, and it's going to have 3 roots. The 3 roots are going to be x equals 0, x equals negative 9, and x equals positive 9. Okay. In part B, we have x squared plus 6x plus 9. Now, if we're going to go ahead and factor this one, again, let's set it equal to 0 first. So we'll have x squared plus 6x plus 9 equals 0. And again, we want to factor it by finding two numbers that multiply to 9 and add to 6. So over here, we're going to have x plus 3 and x plus 3, because 3 times 3 gives me 9, and 3 plus 3 gives me 6. Now, these are actually both the same thing. So what I'm going to actually do here is I only need to solve it once, because by solving it once, I get my answer of x equals negative 3. Even if I did it over here, guess what? X equals negative 3. So what does that mean in terms of a graph, though? So if we were to take a look at this graph over here, and I put in y equals x squared plus 6x plus 9, the reason why there's only one solution is because there's only one 0 on this graph, and that 0 also happens to be the vertex. So if you ever get to a problem that has only one solution, like this one that we just did, it's because the graph is what's called tangent to the x-axis. Tangent is when the line touches in exactly one spot. And there's the one spot that it touches at negative 3. Okay? So let's go back to our question now. And we have part C. And on part C, we have 4x squared minus 25. So again, we're going to solve this one for 0 by, we'll set it equal to 0 first. 4x squared minus 25 equals 0. Now, what we want to do first is we want to look for a GCF, because I see a coefficient in front of the x squared. That's my first thing. But 4 is not divisible by 25. 25 is not divisible by 4. nor it is by 2. So there's no GCF there. But the next step we might want to recognize is that this is a perfect square and that's a perfect square. So what we're going to do there is we're going to factor a difference of perfect squares. The square root of 4x is 2x because 2x times 2x gives me 4x squared. And the square root of 25 is 5. I'm going to separate those with a plus and a minus. All right. Final step, I'm going to set each one of these equal to 0. And then I'm going to solve. So over here, I start off by subtracting 5. And I'm going to have 2x is equal to negative 5. I'm going to divide by 2. I'm going to get x is equal to negative 5 over 2 is acceptable, or we could write negative 2.5. Likewise, over here, we go over to the right. We're going to add 5 to both sides. We're going to get 2x is equal to 5. Let's divide both sides by 2. And again, we can leave it as x equals 5 over 2, or we can make it into a decimal and have x equals 2.5. So the two roots over here are going to be x equals negative 2.5 and x equals 2.5.